Hi, today we're going over section 5.9, complex numbers, powers of I, and conjugates. In this video, we'll talk about the definition of complex numbers, and we'll look at problem number 1 and problem number 2. All right, let's get started on the definition. So, all of a sudden, we had something like x squared plus 4 equals 0 when we were modeling something in the real world, and this is what we got. But then what? How do we solve for x? X squared equals -4. And in order to get x alone, we take the square root of both sides, and all of a sudden, x would equal plus or minus the square root of a -4. So this is the square root of a -1 times the square root of 4. And we didn't know what to do with the square root of -1. The square root of -1, we're going to call that imaginary, and we're going to call that the letter I. So what is I? Just the square root of -1. Why? Because we needed to know how to deal with finding the roots of x squared plus 4. Okay, so that's a little bit about the definition. And now that that makes sense, we need to just think about I. That's the square root of -1. Now, what happens if we square both sides? We know that I squared equals -1. Okay, a little bit about imaginary numbers. Now, they're not real, and so we can't have the set of reals include the imaginary. So we need a new set. And that new set of numbers is called the complex numbers. The complex numbers include a real part and an imaginary part. So A and B are real numbers, but then I, that's the imaginary part. So BI would represent the imaginary part. Let's think about one more chart before we look at how to do that. Okay, when we're talking about I, we see things as we're dealing with it, and then we write something that is mathematically sound. So we're never going to write the square root of 1. We're going to change that to I. So if I see the square root of -1, then I'm going to write I. Okay, and then what happens if I see an I squared? So maybe I'm multiplying and I get I squared. How do I deal with that? We now know that I squared is -1, so we write -1. What if I keep going with powers of I? So what about I cubed? What if I see I cubed? So I'm going to multiply I times I squared. So that would give me a negative I. So we're not ever going to write I cubed. In the process, we can write it, but then when we fully simplify, we're going to write -I. And then what about I to the fourth? Okay, so I to the fourth is I squared times I squared, which would be -1 times -1, +1. All right, now let's try I to the fifth. So if we try I to the fifth, it's going to bring us back here to I because it's 1, I to the fourth, times another I. This is I to the fifth. And you just keep seeing this pattern repeating and repeating and repeating. And we'll see that in this chart up above in just 1 second. All right, this would be I to the fifth, I to the sixth, I to the seventh, I to the eighth. You notice that the pattern repeats in a group of 4. So if I'm asked, like on problem number 1, to find I to the 101st, how do I do that? Should I just count through my chart? Like, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll just keep counting until I get to 101. No, we have an awesome operation that deals with grouping. What is that? Division. Okay, so whatever number you have, let's say I have 22. Let's say I have I to the 22nd power. So you take 22 and you divide that by 4, since there are 4 in our pattern. We don't really care how many times it goes in. What we care about is the remainder. So I don't care about how many times I'm counting down the chart. I want to know where I land when I'm done. So This would be 5 remainder 2. So that's this column, the remainder. If it's a remainder 1, it's I. Remainder 2, -1. Remainder 3, -I. And a remainder of 0. Because when you're dividing by 4, you don't get a remainder of 4, or you should have gone in one more time. Okay? So this means I would go through this 5 times, and then I would say 20, 21, 22, and I would land right here on -1. So if they ask you, hey, what's I to the 22nd? You would say -1. That's how it works every time. We see these different powers of I. This is what we write. And then we take the remainder. So it's just repeating and repeating and repeating this pattern. I encourage you to copy this little chart down in your notes so that you can use it as you work with I squared, I cubed, I to the fourth, and then other various powers of I. Now that we can see the pattern, let's go back and fill in the chart. We know that I is I squared is -1, I cubed is those put together, -I, and I to the fourth is tacking on one more I, which would give you negative I times I squared, which is -1. So you get +1, the negative times the negative +1. We know that's our pattern. If we tack on one more I, 1 times I would be I. And then tack on one more I, so that's I squared, which is -1. And then another I, -I, and another I, 1. And we see this pattern repeating and repeating. So I, -1, -I, and 1. Now, how do I find these other powers of I? Let's use our little trick. I just see where I'm going to land by considering the remainder. So just remember the remainder for I is 1, I squared is 2, I cubed is 3, and I to the fourth is 0 if it goes in evenly. All right, so let's take 42 and divide it by 4. So that goes in 1, remainder 2. Okay, so it goes in 10 times, remainder 2. If the remainder is 2, I know that I write -1. How about 36? 36 divided by 4 is 9, remainder 0. So I write 1. How about 25? 25 divided by 4, it would go in 6 times with a remainder of 1. So I write I. What about 47? So 47, 4 would go in 11 times. So you'd get 44, and then with a remainder of 3. And if I have a remainder of 3, I write -I. Isn't that fun? You just divide by 4, consider the remainder. Okay, let's do problem number 1. Take a second, pause the video, do problem number 1 on your own. Okay, let's see how you did. So 33 divided by 4, it goes in 8 times, so a remainder of 1. What is the remainder of 1? So I to the 33rd would be I. What about 101? So same thing, take 101, divide by 4, so it goes in twice, and then 21 5 times, and then a remainder of 1. Remainder of 1, once again, I. Okay, that just means I'd go through that chart 25 times, and then I'd end up on the first spot when I counted to 101. Let's try problem number 2. How do I write as a product of a real number and I? So I'm taking the square root of -25 and thinking about that as the square root of -1 times the square root of 25. The square root of 25 is 5, and the square root of -1 is I. Let's look at B. I have a negative out front, not subject to the square root. So I have negative, and then I have the square root of -1, and then I have the square root of 81. So this would be this negative out front would stay there, negative. The square root of 81 is 9, and then the square root of negative 1 is I. And then the last one, I have the square root of negative 1 times the square root of 7. And the square root of 7 is not a perfect square, so I'll just leave it alone. So root 7, take out the square root of negative 1 and call it I. All right, now you know a little bit more about complex numbers, and I'll see you next time.